Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 74 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from Quant. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to our channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. Once you get sign up, you will get an access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD, and VRC. We will be uploading 100 tests in each section. Right. So if you're a serious CAT 25 aspirant, you cannot afford missing these tests. These tests are absolutely for free. And these tests have questions handpicked by us. And without any further delay, let's get started with the first question. Coming to the first question, a solid metallic cube is melted to form 5 solid cubes whose volumes are in the ratio 1 is to 1 is to 8 is to 27 is to 27. The percentage by which the sum of the surface area of these 5 cubes exceeds the surface area of the original cube is nearest to. Right. Now, here I want you guys to understand that volume of a cube is equal to a cube or directly proportional to cube of its side. Right. And surface area is proportional to square of the side. Right. Now we are given with a solid metallic cube is melted to form 5 solid cubes whose volumes are in the ratio 1, 1, 8, 27 and 27. Now let me consider the volumes of these 5 cubes to be 1, 1, 8, 27, 27. So what should be the volume of the larger metallic cube which was melted? Right. Sum of all these volumes. Right. So there should not be any change in volume. Right. So 27 plus 27 plus 8 plus 1 plus 1, 10, 10 plus 54, 64. So we have a larger metallic cube of volume 64 cubic units and melted to form 5 cubes of volumes 1, 1, 8, 27 and 27. Right. So if the volume is 64 cube units, the side of this cube will be 4 units. Side of the smaller cubes now. Now this should be 1, 1, then this would be 2, then this would be 3 and this would be 3 because volume is directly proportional to a cube. Now if the sides are 1, 1, 2, 3 and 3, then the surface areas will be proportional to square of its sides. So this will be 1, 1, 4, 9, 9. Now the surface area of the larger cube would be 16. Right. Now what is the sum of all these surface areas? Right. So 1 plus 1, 2, 6, 6 plus 18, 24, and this would be 16. But they are not 24 and 16. Now this is 24 into 6 and 16 into 6. Now we have 6 common, but because the surface area of cube is 6a square. Now what was asked? The surface area of these 5 cubes exceeds the surface area of the original cube. So 24 into 6 minus 16 into 6 by 16 into 6. Now you can eliminate 6. So that's the reason I did not consider 6 here. Right. Now 24 minus 16 is 8. 8 by 16, 1 by 2, which is nothing but 50%. Hence option B should be the answer to this question. Now coming to the second question, for how many integers n will the inequality n minus 5 into n minus 10 minus 3 into n minus 2 less than 0 be less than or equal to 0 be satisfied? Now let me expand this. Then we'll be having n square minus 5n minus 10n plus 50 minus 3n plus 6. This should be less than or equal to 0. So we have n square minus 5n minus 10n minus 15n minus 15n minus 3n minus 18n plus 56 less than or equal to 0. Now we need to split 18 or minus 18 as a sum of two numbers. Right? When multiplied, the result is 56 minus 4 into minus 14. Right? So I can write this as n square minus 4n minus 14n plus 56 less than or equal to 0. Now taking n common, you have n into n minus 4. Taking minus 14 common, you have n minus 4 less than or equal to 0. Right. Now taking n minus 4 common, you have n minus 4 into n minus 14 less than or equal to 0. Now let us plot these values on the number line. So we have 4, we have 14, right? For all the values greater than 14, positive, 4 to 14 negative, and this positive, right? And this is less than or equal to 0, so the values should be between 4 and 14 including both, right? So when I have to include 4 and 14, counting rule, 14 minus 4 plus 1, 10 plus 1, 11 should be the answer to this question. Now coming to the next question. 8 teams take part in a tournament where each team plays against every other team exactly once. So round robin. In a particular year, one team got suspended after playing 3 matches. So every team will be playing against the other 7 teams, right? So you have only one team that played 3 matches. So it did not play 4 matches. Okay. Due to a disciplinary issue, the organizers decide to proceed nonetheless, with the remaining matches, the total number of matches that were played in the tournament that year is, right. So in a round robin tournament, you have n teams, right. So you have a team playing with all the other teams. The total number of matches would be nc2, which is nothing but selecting two different teams of n teams. So here we have 8 teams. So the total number of matches would be 8c2. So that would be 8 into 7 by 2 factorial 2. 4. So there will be total of 28 matches, but you have one of the teams playing only 3 matches that did not play the other 4. So the total number of matches held would be 28 minus 4. 24 should be the answer to this question. Now coming to the next question, if m and n are two positive integers such that 7m plus 11n is equal to 200, then the minimum possible value of m plus n is. So 7m plus 11n should be equal to 200. Now, given that m and n are positive integers, we need to find the minimum possible value of m plus n. Now, first, let us find the integral values of m and n which satisfy this equation, right? When n is equal to, let's start with maximum value of n, right? So 11 into 18 is 198, right? So if this is 18, then 198, 7m cannot be 2, right? Now 198, 187, 187, 200 minus 187 is 13, not possible. Then 176, 200 minus 176, 24 is not a multiple of 7, not possible. 165, right? 11, 15 is 165, and 200 minus 165 is 35, which is multiple of 7, right? So when the value of n is 15, right, 11 15 is 165, balance is 35. So the value of m has to be 5. So 7 into 5 is 35, 35 plus 165 is 200. Now once you have this, the next value of n would be, you have to reduce that by the coefficient of m. Now 15 minus 7, 8, and the next value of m will be, add the coefficient of n to this, right? So 5 plus 11, 16. Then subtract the coefficient of m here. 8 minus 7 is 1, and the next value of m would be 16 plus coefficient of n, which is 11. 16 plus 11, 27. Now the next value of n would be 1 minus 7. Not possible because the values of m and n, they have to be positive. So we have 5, 15, 16, 8, and 27, 1. So 5 plus 15 is 20, 16 plus 8 is 24, 27 plus 1 is 28. Now we are asked to find the minimum possible value. So 20 should be the answer to this question. Now coming to the fifth question, the number of factors of 3 power 5 into 5 power 8 into 7 power 2 that are perfect squares is. Now for a factor to be a perfect square, right? So all the prime factors of that factor should be to the even powers, right? So we have 3 prime factors, 3, 5, and 7, right? So the powers of these 3 prime factors should be even numbers. So 3 power 0 is one possibility, then 3 square, then 3 power 4. We cannot have 3 power 6 because the highest power of 3 is 5. Now similarly, 5, 5 power 0, 5 power 2, 5 power 4, 5 power 6, and 5 power 8. So you have 5 possible values in the powers of 5, right? Now coming to 7. 7 power 0 and 7 power 2. Right? Now all we need to do is we need to select one out of these three. In how many ways can we do that? 3 ways into one out of these 5 ways into one out of these 2. Now 3 into 5, 15, 15 into 2, 30 should be the answer to this question. So there will be 30 30 factors of 3 power 5 into 5 power 8 into 7 power 2 that are perfect squares, right? And those perfect squares will be, see, 3 power 0 into 5 power 0 into 7 power 0, 3 power 0 into 5 square into 7 power 0, 5 power 4 into 7 power 0, 5 power 6 into 7 power 0, 5 power 8 into 7 power 0, right? Similarly, 3 square into 5 power 0 into 7 power 0, so on. You will be having 30 numbers which are factors of 3 power 5 into 5 power 8 into 7 power 2, which are perfect squares.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.